Hey guys, so in this lesson we're learning about our half angle identities. So in 5.5 we learned about the double angle identities. So those were finding like double the angle that you were given. So these are finding half the angle that you were given. So we're going to start right off the bat solving or verifying an identity. But first I'm going to rewrite this so you understand it a little bit better. So this really says sine of x over 2 or plus cosine of x over 2 squared equals 1 plus sine x. So for this one, I hope you're looking at it and thinking that you should FOIL this because that's what we're going to do. So we're going to start out by FOILing. So remember to write both parentheses if that helps you when you do your FOILing. So we would end up with sine squared x over 2 plus 2 sine x over 2 cosine x over 2 plus cosine squared x over 2. So from here we could do a couple different things. What I see is that this is equal to 1 cosine squared plus sine squared is equal to 1. So we can change that to 1 plus 2 sine x over 2 cosine x over 2. So from here, we look at this. This is our double angle identity for sine. So that would be 1 plus sine 2 times x over 2. So that's 1 plus sine x. So if you didn't get what I just did, when I did it earlier, I solved it a different way. So I'm going to show you that because I didn't even think of this way right now. So what I did is once I, what did I do? Oh, I plugged in, I moved this around. So sine of x over 2, I plugged in the identity for that. Cosine of x over 2, plugged in that identity. And then the 2 sine times cosine from right here. So I was using the double angle identities, or the half angle identities. And then when you're squaring a square root, it simplifies to get that. They have common denominators, so you can add the numerators. Here, you times the insides. I FOILed the top. And then I changed 1 minus cosine to sine squared. You take the square root, we get that, and then the 2's would cancel. So that's just a different way to do it. Remember the identities, there's a bunch of different ways you can try them. So whatever way you like best. Remember, if you have questions, remind yourself to ask me tomorrow. So let's take a look inside. Those problems on the top all go together, and it's based off of this information on the left side. So they told us that cosine is 2/3 and theta is in quadrant 4, and then we want to find all those half angles. So let's draw our picture. So if cosine's 2 over 3, we have adjacent over hypotenuse. So to find that third side, we'll do the Pythagorean theorem. So 2 squared plus y squared equals 3 squared. So we get that that side is the square root of 5. So remember to make it negative since it's on the negative y-axis side. Okay, so we want to find sine of theta over 2. So if we take a look, our identity for sine is that this is equal to the square root of 1 minus the cosine of theta over 2. So now we need to plug in what we know, which is the cosine of theta. So they had given us that, so we can plug that right in. So this would give us, well, write it down, we'd have 1 minus 2/3 over 2. So we can simplify the numerator. So 1 minus 2/3 is 1/3 over 2. So flip and multiply, we would have 1/3 times 1/2. we got 1/6. We can take the square root of 1, so we'd have 1 over the square root of 6. And then if we rationalize, we end up with the square root of 6 over 6. So if cosine of theta equals 2/3, cosine of theta over 2 equals root 6 over root 6. Or I'm sorry, root 6 over 6. Okay, so why don't you try the cosine? It's pretty much the same. The only difference is that it's a plus here instead. So it's just going to change your numbers a little bit. So go ahead and try that, and then when you come back, I will show you what the answer is. You can try the tangent one too. So try cosine and tangent, and when you come back, we'll talk about the answers. Okay, so for cosine, the difference was that it was plus, so we ended up with 5/3 instead of 1/3 like we did before, and then we get root 30 over 6 after we simplify everything. For tangent, the tangent formula is a little bit different. You have 3 ones to choose from, so I just chose this one. I just didn't want to deal with the square root. And then here I have the sum or the difference in top instead of being a sum in the bottom. So it really doesn't matter which one you choose, you should get the same thing. So we plug in what we know, which is our cosine. And then we'd have to find our sine from our picture, which is why we had to draw the picture. And then, oh, I did some fancy math there. What did I do? Do you guys know? So I times the top and the bottom by 3. So that's like multiplying by 1, really. But then you distribute, so it cancels out the fraction and a fraction. And then you rationalize. I lost my negative sign though. Okay, so it should be negative root 5 over 5. Okay, good job. So let's try to find some exact values from the bottom. So this is over 2, so we're dividing our angles by 2. So if we want to figure out what 15 is, or cosine of 15, it's like you would double it. So the cosine of 15 is the same as the cosine of 30 divided by 2. So this is like our theta. Okay, so when we are plugging stuff in, we're plugging it in for 30. So I'm just going to draw my 30 triangle over here real quick. Okay, so we know that our formula is equal to the square root of 1 plus cosine theta over 2. So the cosine of theta, which is 30, would be from over here. So cosine is root 3 over 2. So we have the square root of 1 plus root 3 over 2 over 2. So I'm going to do that fancy times thing like I did in the last one to get rid of the fraction. So I'm going to times the top and the bottom by 2. So that would give us, distribute 2 plus, cancel the fraction, root 3 over 4. And then taking the square root of the bottom, I would have just a 2 on the bottom. So the top has the square root of 2 plus root 3 over 2. And that is where we're going to leave it. I know when we did the sum and difference identities previously, and we did the cosine of 15, we got a different answer. Because if you type it in your calculator, you get that, root 6 plus root 2 over 4. But if you make that a decimal, we get 0.9659. And if we were to change this to a decimal, we would get the same thing. It's just a different version of that number. So it's the same answer, just it looks a little different. Okay. So for the cosine or sine or tangent of 15, you can use either the sum and difference identities like we did previously, or you can use these new half angle identities. So our last example is another one using a half angle identity. So they gave us the tangent of 22.5. So the tangent of 22.5 would be the same as the tangent of 45 over 2. So our theta is 45 here. So pick any tangent formula you want. So I used 1 minus the cosine over the sine of theta. So remember our theta is 45, so we'll plug that in. So 1 minus the cosine of 45 over the sine of 45. So remember, cosine and sine of 45 are both root 2 over 2. So we have 1 minus root 2 over 2 over root 2 over 2. So I'm going to do the same fancy magic I did before, times the top and the bottom by 2. So we get 2 minus root 2 over root 2. And then we would have to rationalize our denominator. So times the top by root 2 and the bottom by root 2. Remember, on the top you're distributing. So that would give us 2 root 2 minus 2. Because root 2 times root 2 was 2 over 2. And then we can simplify that. So we'd have root 2 minus 1. So if you use your calculator, 22.5. Oh, it didn't give us an exact value. That surprises me. It does that for all the other ones. Maybe if we did 45 over 2. Nope. Calculator's making me... I guess it doesn't work every time. It doesn't want to do it. Okay, well, you do have an exact answer for that one. Root 2 minus 1. Okay, so if you had any questions, make sure you ask in class tomorrow. Warner out.